Hi, I'm Tinker. I hope to show you a few things that will help you in deciding which type of power inverter you may wish to use. Some may work fine, but some others can do damage. The first will be a 75-watt plug-in car type unit. The next will be a 150-watt plug-in unit, then a 200-watt plug-in unit, then an 800-watt unit that can be used on a solar or wind unit battery supply, and finally a 300-watt true sine wave inverter plug-in type.
What is the difference? What is a watt? What is a plug-in type? Tinker, please explain the what is watt.
Thanks for asking. A watt is a form of electrical energy that can do work for you, like to illuminate a lamp or do your laundry or run a motor. It is the result of voltage, which is the source to move electrons, which is small particles of negative parts of the atom, and the current, which is the force of how fast the electrons travel through a device, measured in amperes. The end result in our case is the watt as our form of energy. Therefore, we will take one type of energy for our inverters and convert it to a more usable form of energy that we are familiar with, namely the same type of power used at home. Most of us may be familiar with power generating stations. They use steam or water pressure to push a turbine on a generator to produce the power we use, which is alternating current or AC. Since we want to produce our own AC to use when we want and where we want, we have to use an inverter which has a circuit to produce a small square wave type AC signal, which then gets converted to a higher voltage with its internal transformer and electronics. So it's basically made up from electronics, which leaves us with a bit of a dilemma. How can we get a nice, clean, proper sine wave to run our appliances? We now need more electronic parts to try and create what we need. In come the inverters. There used to be a square wave output inverter, which basically hammered the appliances from the inside, thus destroying them. I personally have not seen one in years, but they do make a true sine wave, like what comes out of the wall, or a cheaper version called a modified sine wave, which is a mix between the true and the square. Yes, it makes noise in the appliance, depending on what type of appliance it is. But for items like transformer chargers or heaters and similar devices, they are fine and much cheaper to purchase. However, for items like microwave ovens, we should use the true sine wave. For the purpose of this demonstration, we will be using a variety of inverters. They all will work, however, they do have a power rating in watts for small appliances to larger. However, they do consume power, and the larger the wattage of the unit, generally the higher the power consumed just to run the electronics within the units. The first unit is the smallest in my portfolio. It's a 75 watt, which can run basically things up to 50 watts, as when it gets to its rated capacity. It tends to get overheated and can lose its wave or get out of shape, making it inoperable. Because it's a small unit, the basic operating consumption is only 61 milliamps just to run the internal electronics with no load. My next sample is a 150 watt modified sine wave, as was the 75 watt. The so-called phantom power usage on this one is 109 milliamp, considerably more as the units are larger to handle the load. On this 200 watt inverter, also a modified sine wave, the current is increased even more. This one is 123 milliamps or 1.85 watt, just to have it on and nothing running anything. The last of my modified sine wave inverters is probably the best quality, as this unit is designed for an off-grid system with battery protection, and based on the power consumption to run this 800 watt unit, it is only 1 milliamp more than the 200 watt unit. So quality does matter. The final unit for examination is a 300 watt true sine wave. Even though it's only 300 watt, it is much more expensive than the others, and as you can see, the power usage to have it on is much more compared to the modified waveform units. The modified wave as seen here will work on a lot of items. However, not properly on everything, but the true sine wave as seen here mimics the power supplied by the local utility. However, keep in mind that any waveform inverter, if left on, will drain the battery to destruction unless it's one designed for a standalone system with protection. What happens then is that the battery will still be depleted, but only to the safety rating of the inverters so as not to destroy the batteries. The cheaper units, without this safety feature, will truly damage your supply. In closing this discussion, please be aware that if your 120 volt appliance draws 120 watt, Then divide the wattage by the voltage to get the ampere or current consumption. On the 120-volt side only, please consider where the power is coming from. It's coming from a lower voltage, like a 12-volt battery, therefore aside from the power used to run the inverter. You take the wattage, example 120 watt, and divide that by the battery voltage. Therefore consider 120 watt divided by 12. The battery draw will be 10 amps. Example, if a microwave is 1000 watt, then the consumption in amps will be 8.3 amp at 120 volt and 83 amp on 12 volt. Bottom line, if you're thinking green, make sure you turn off things to save on battery power. Until we meet again, I am the Tinker.